Radio TV Phono Nut here, and we have a 10-inch General Electric color TV from 1983, and GE made about 10 billion of these sets, both under their own brand name and for a few department store brands, including Western Auto under the True Tone brand, J.C. Penney, and I'm pretty sure there were some Montgomery Ward airline versions of this set made. Now this was the replacement for the tube-type Portacolor 10-inch televisions, which were first introduced in about 1966. Maybe an airplane's fixing to come drop one over my head right now. But the tube-type Portacolor went through several variations and was finally discontinued sometime around 77 or 78, and it was the last tube-type color TV known to be manufactured for the USA market. There's been reports of them being made as recent as 1980, but I've never seen any actual evidence of that. 77 is the newest one that I've actually seen any reference to. But in the early 70s, sometime around 73, but anyway, as I was saying, sometime around 73 or 4, GE introduced the solid state Portacolor 2, which used the 10QA chassis. I have one of those, but it's in rather poor shape, but maybe we'll try to resurrect it one day. But that chassis proved to be unreliable, and for GE to pull production of it because it was unreliable, then it must have been really bad, because GE sets from that era weren't really known for reliability even on a good day. But when the Portacolor 2 solid state version was discontinued, they continued to make the tube type Portacolor until it was officially discontinued in 77 and replaced by the 10AA chassis, which was basically this set here. But like I said, there's been reports that the tube type Portacolors were still being rolled out a little later, probably just using up excess materials. But these solid state sets are unofficially known as the Portacolor 3 among collectors, but I don't think there was ever any mention of that in GE literature. But the first versions of these were made in 77, used an AA chassis, and then that evolved into the AB chassis, which was very similar, which is what this one is. And then I think there was an AC chassis, and these were made from up until at least 1985, so they were a very popular television. And then in 1986, GE bought out RCA and closed their own TV plants, and for a while there, most GE televisions were just a rebadged RCA, or they were a rebadged Panasonic or Gold Star. And then in 1988, GE sold the RCA and GE Consumer Electronics lines to Thompson Consumer Electronics, and then it was pretty much all over at that point. Now, I got this set somewhere probably 15 or more years ago, and I want to say at the time it powered up and produced a picture, but after being in storage for all these years, I plugged it in, and we had sound and no high voltage crackle for about 3 seconds, and then it just went totally dead. So let's try to figure out what's wrong with it and see if it's worth trying to repair. The main problem that these sets gave were what was called griplets, and that was a feed through that connected the top and bottom sides of the circuit board together. Well, over time in the heating and cooling process, those griplets would break loose, and you can resolder them and they'll last a little while, but the only way to permanently fix them is to run a piece of wire through the griplet from top to bottom of the board and solder it, and then it shouldn't give you any more problems. And the griplet situation plagued a lot of GE solid state sets from the late 70s and early 80s. Now these later ones, like this one, had a better picture than the old Portacolors did. It wouldn't have taken much to have a better picture than a Portacolor, but you'll have to give GE credit. They were, to my knowledge, the first ones to roll out a small screen, lightweight for the time, portable color TV. And then of course by the late 60s, early 70s, the Japanese were rolling out small screen color TVs, most of which were solid state. But I guess in 1966-67, people weren't too concerned about picture quality. They were just happy to have a small screen portable color TV that they could tote around with them. Here's the back of the chassis, strictly a carryover from the 1970s. This uses the GE large neck inline gun tube. It's very similar to what the old Portacolor sets used, only I think this later tube has a different pin out than the original Portacolor tube, but the technology is very similar. And here's our flyback transformer and high voltage rectifier. And then there's a focus divider back here. And then our usual printed circuit board. So let's plug it in and let's see what happens. Alright, let's see if it does anything now. Nope, totally dead. No sound, no high voltage, no nothing. Well, we're not getting off to a good start here. The fuse is blown, and the next thing I want to check is the horizontal output transistor and make sure it's not shorted by the fact that it came on with no high voltage and sound. Doesn't really point in a good direction. Okay, I want to check the horizontal output transistor. I have the negative lead of my meter clipped to ground, and I'm on the continuity test, and I'm going to touch the positive lead to the case of the transistor. Okay, I'm not getting a dead short. That's a good sign. So let's pull the transistor out of the socket and check it more thoroughly. It could have leakage though. And I have the transistor out of circuit, and thankfully it just plugs in. Reading from the collector to emitter, we get an open on the diode scale. That's good. And then we reverse our meter leads. We still get an open. Now let's move from collector to base. Alright, collector to base, I'm getting a 0.417 voltage drop. And when I reverse these leads, I should get nothing. And leads reversed, and I get nothing. So far, so good. Now let's check between base and emitter. No reading, good. Now let's reverse the leads, and we should get a reading between base and emitter terminals. And I get a voltage drop of 0.519. So theoretically this transistor is not shorted and it should still function. And let's try to keep it from shorting, because these are getting hard to find. This is probably either an NTE 238 or an NTE 165. And I bought a bunch of them back in the day, and they were not cheap. I'm thinking around 20 bucks. And what would really piss you off was to replace one of them and turn the set on, and it would blow it instantly because of another fault. And usually horizontal output transistors don't short on their own. Usually something helps them. Now, one of the nice things that GE did, and I know of no other manufacturer who did this, well, Setchell Carlson might have done it back in the tube days, but GE put what they called a mini manual in a little compartment on the back of the television. Only problem was that mini manual usually ended up disappearing after the first shop it went to, especially if that shop was a bit dishonest. And GE even put a notice that says, "Service information is customer property. Please replace when finished or something like that. But like I said, some shops didn't heed that notice. Right, here's a block diagram of our power supply, and we have our bridge rectifier that provides 145 volts to the horizontal and vertical sweep circuits, and then we have this SCR here that starts up the horizontal oscillator, which initiates horizontal drive and allows the flyback transformer to produce scan-derived voltages to the audio circuit and other places. Now, because we have audio, or had audio before things went dead on us off camera, then that tells us that the horizontal drive and oscillator and all that is working properly, and that there was something coming off the flyback. But I am concerned that I didn't feel any high voltage crackle on the screen when I turned it on. So most likely what's the culprit is the high voltage rectifier inside of the transformer is shorted, and that's what popped the fuse. So I think next we're going to substitute the fuse for say a 60-watt light bulb and see what happens, and then maybe we can do a little troubleshooting. Okay, here's our setup. I have the 60-watt incandescent light bulb connected in place of the blown B+ fuse, and then I have our DC voltmeter on said B+ line, which I believe is 145 volts. Then we have the TV plugged into our variable isolated power supply, and we're going to start at about 70 volts and see what happens. So let's see. That drew an excessive amount of current there, over 3 amps. Okay, so that was the initial turn on surge, so let's turn it back on. And now we have sound and all this pulsating crap, and about 91 volts B+ and no high voltage. So that does not look good. Now we got my high voltage probe attached to the CRT anode, and we're not getting any discernible high voltage at all. And our B+, we're up to about 110 volts AC input, is only about 87, 86 volts. So the light bulb, of course, is going to be limiting some of that, but it's being a pretty heavy load placed on our power supply. And since we obviously have some scan-derived voltages developed, that tells us the horizontal drive is working, but we have no high voltage being developed, since starting to look more and more like the flyback is the culprit. Alright, our 22 volt scan-derived source is reading about 12, so it's very low too, which is no surprise. But we know like I said before, we know our horizontal drive is working, because if it wasn't, there wouldn't be anything off of our scan-derived sources. Yeah, it looks like the part number for the flyback is EP77X44. Yeah, good luck on finding one. I think pretty much all of the old school GE parts pretty much disappeared not long after Thompson took over, so unless there's a new old stock one somewhere, then we can probably just forget it. And I will say that these early General Electric integrated flyback transformers didn't hold up all that great. The worst one was the one used in the 25-inch YM chassis, which to my knowledge was the first 25-inch TV by anyone that used an inline picture tube. I think it came out late 76 for the 77 model year and was made through about 80 or so. And I think that was also the first 25-inch TV made by anyone to use an IHVT style flyback transformer, meaning the transformer, the tripler, and all of that was enclosed in the same package. In the old days, you had a separate transformer and tripler, and yes, triplers were high failure parts, but those were pretty much universal items. And when the tripler failed, you could usually get a replacement without much trouble. When they went to the IHVT style flyback, those were pretty much model specific, or to a very narrow range of models, and you pretty much had to go with either the factory part, or there were some companies that made generics, but generally speaking you were better off going with the factory part. Now in the old tube set days, the flyback for the CTC 38, actually the factory part was inferior to the Thordorson replacement. So let's go see if we can find what we can find for this. I'm not really holding out any hope. EP77X44. Alright, just making further measurements, trying to cover all my bases. I'm checking the continuity between the collector of the horizontal output transistor and ground, and I'm reading 23k ohms, which that seems low to me. So we're going to start disconnecting stuff, and just to make sure that it's not something else that's causing the issue. I did an eBay search for that flyback part number, 0 results. I did a Google search for that flyback part number, 0 results. So if that turns out to be bad, then my only hope is to find someone in one of the TV groups that has some old GE part stock left over and would happen to have one of those flyback transformers. And before anybody jumps on me, no, I'm not expecting free parts. And I bring that up because about 2.5 years ago, there was a guy in one of the Facebook groups that I help run, and oh, he was a real smart butt. He was always popping off at people, and he popped off at me a couple of times, and the final straw was whenever I was on there asking for a part, and he jumped in, yeah, you're on here expecting people to bail you out for free, and yeah. So that was the final straw, and I booted his butt. And then I got a nasty message through Facebook from him telling me that he had people who lived in my area, and I know he did because I'd already looked at his profile. In fact, I think he was the son of a local lawyer who had deceased. But he let me know that he had people in this area, and how dare I boot him from that group. And I'm going to F you up real good, and it's going to come when you least expect it. And I didn't even bother to respond to him because there's an old saying I've always heard, don't feed the troll. I feel like pretty much what that boiled down to is he was just a little spoiled rich lawyer's kid who had always gotten his way, and then somebody, namely me, told him no, and he just couldn't handle it, so he lashed out. Only thing I did, this was not long before my mother got sick for the last time, I made her aware of the message in the event that something happened that she could give his name to the cops. But anyway, let's start pulling stuff loose here. I noticed on the schematic this TV has one of those, if I can find it here. Where is it? Where is it? Let's try to find it. Right there. It has one of those 4-lead safety capacitors that was so common in 1970s era TVs. Zenith and Magnavox especially loved them. And it was these safety capacitors in the early Zenith Chromacolor 2 sets that the end would blow off and cause the high voltage to skyrocket and blow the neck off the picture tube. And the same thing happened in some of the Magnavox sets that used them. What was supposed to happen is if that safety capacitor blew open, the connection at the end was supposed to break. So theoretically, if the capacitor blew open and the end connection broke, it would depend on which end broke loose, but there would be no more collector connection or emitter connection. Like I said, whichever end broke loose, but when the capacitor opens, you have no capacitor there, but you still have the collector or emitter connection in place. And I think it was usually the collector end that blew open, and then that's what causes the high voltage to skyrocket. Now in the later Magnavox sets, like the T815, T809, T991 chassis, most of the time these capacitors dead shorted. And in a case like that, that would be preferable, because all that's going to do is trip the circuit breaker on the TV. Now Zenith, once they had that fiasco with the white capacitor blowing apart, they started using a Sprague orange drop, and I don't ever recall running into one of those that was bad. This GE appears to have one of the old gray paper and oil type capacitors that Magnavox used. Now, I've never seen one of these become leaky. I've seen them short, I've seen them blow open, but I've never seen one become leaky. Will that be the case today, or do we still indeed have a bad flyback transformer? Now, I have this thing sort of torn apart here. Now when I unplug that connector from the horizontal output assembly, it's what we'll call it anyway, from the circuit board, I was no longer getting a 24k ohm reading from collector to emitter of the hot, and that's because I think we broke the ground when we disconnected that. But whenever I check directly at the terminals of the hot, I get 24k ohms between collector and emitter, and that's with the hot out of the set. So in the flyback, I think I've got the flyback fully disconnected, but with GE packing everything in here, it's kind of hard to tell. So it's looking like we might either have a leaky safety cap or a leaky damper diode. So let's do some more investigating before we condemn this flyback. Okay, I have removed the whole horizontal output assembly from this set. Makes it a lot easier to get to everything in it. There's our damper diode right there. There's our 4-lead safety capacitor. Alright, I pulled out this old Syncor 1990s era TV analyzer. And it has a flyback ringing test on it, but unfortunately this knob, this switch, is stuck like Chuck. I could turn it with the vice grips and it says 10 rings or greater. The most I can get out of this is about 8 rings, so we're going to say this flyback is bad. Now, I'm supposed to have an older Syncor analyst as well as an old handheld Syncor ringer. I can't lay my hands on either one of them, and I'm not in the mood to tear this place apart trying to find them, only to find that those two pieces will probably have issues now anyway. But yeah, I'm pretty confident this flyback is the problem, and if we can find another one, great. If we can't, then this TV is never going to live again, and that's just the way it is. So if I find a flyback, you'll see a part 2 to this video. If I don't find a flyback, you won't see a part 2 to this video. Alright, I'm in the process of trying to put this thing back together just so it won't wind up being a disassembled mess in a box over here. So when the time comes that we find a flyback, then we can put it back together. But I wanted to show you what a griplet looks like. That right there is an example of a griplet. And over time, from the heating and cooling cycles of repeated use, they break down and the connection fractures, and they no longer make contact between the top and bottom of the circuit board anymore. And there's the bottom end of said griplet. where that wire is pointing. Now, for a temporary repair, maybe a couple of years, 2 or 3 years, you can resolder the griplet top and bottom. But for a long-lasting repair, you have to just desolder as much of the old solder as you can and take a small drill and drill out the old and just run a piece of wire through from the top to the bottom, bend it over and solder it. But I'm not going to all that kind of trouble on this, something that we don't know if it's ever going to work again. Now if we get a flyback or find what else might be wrong with this, if by some chance it isn't the flyback and we get it working, then we'll pull this board out and go over it, but there's no need in doing that right now. Okay, we're back together except for putting the back in place and except for putting some wire ties back in place, but there's really no need in doing that until the set is repaired, if it gets repaired. Now I'm going to try one other thing that someone reminded me of. I remember GE had issues with bad yokes, and someone reminded me to power the set up with the bulb just like I did, only this time do so with the horizontal yoke winding disconnected and see if we get any high voltage. Of course it probably won't be full high voltage because that yoke is part of a tuned circuit, but if we get any high voltage, then it's probably not the flyback, it's probably the yoke, but I'm still leaning more towards the flyback, but we'll see. We're at 0 volts. Let's see what happens. It still looks like it's doing the same thing. Do we have any high voltage? Not one bit. Now I smell something burning. And smoke. We have smoke. We have smoke coming out of the flyback transformer. So, yeah, I think that pretty much confirms it. Or we have smoke coming from somewhere close to the flyback. Now, as far as what's wrong with this TV, it's stuff like this that's going to send a lot of TVs to the graveyard. Not just General Electric sets, but all what we'll call later model CRT televisions from the 80s on to the end of the CRT era, because things like flyback transformers, yokes, specialized integrated circuits, stuff like that, they are eventually going to fail. And back in the 80s and 90s and into part of the 2000s, there were companies manufacturing replacement parts such as flyback transformers and certain integrated circuits, etc. But once CRT televisions fell out of the mainstream and people stopped having those repaired, then pretty much all of the companies that were making generic parts went away. So there's nobody that I know of making things like generic flyback transformers and stuff like that. And then NTE, that was a large supplier of generic semiconductors, recently went out of business. So when things like this horizontal output transistor blow up, then it might be a bit of a challenge to find one. Now, right now, I could probably find one with a little looking, but 10 years from now, who knows? Now, as far as this flyback transformer, I'd say that part probably hasn't been available through GE in at least 30 to 35 years. Like I think I've already said, a lot of those older GE parts went away once Thompson took over. So the only hope that this set ever has of working again is if I run across a really beat to heck junk TV that's got a good flyback in it, or if I happen to run across somebody who has a stash of new old stock GE parts that were never used, and they happen to have a flyback transformer. But other than that, there's not much to this television. Now, I think there's another one of these sets here that's an older one. I want to say from about 78 or 9. And I want to say it was dead too, so it might have the same thing wrong with it. It's hard to say. The more I think about it, when I got this set probably 15 years ago, if not longer, I want to say it had a picture on it, and it's just been sitting here ever since then. And then whenever I turned it on, then the flyback decided to let go. So I will now shut up, and we will post this video. And like I previously said, if I find a flyback transformer, then there will be a part 2. If I don't find a flyback transformer, then it'll all end right here. But I'm not going to throw the TV away. I'm going to button it back up, and yes, I've already stuck the little manual in the little compartment on the back of the set. So, what I could do with this is just advertise it on eBay as an untested TV, retro gamers TV, untested. Don't know if it works, for $300, and then somebody with more money than sense would eventually come along and buy it. But no, all jokes aside, I don't do business like that. Me knowing what's wrong with it, there's no way I could advertise this TV for sale and play stupid like it's untested. We don't know anything about it, because 9 times out of 10 when somebody on eBay says untested, that means they tested it and it didn't work, and they're playing stupid. Now, as far as what I said earlier about that person raking me over the coals thinking that I was looking for free parts, I will say that over the years people have been very generous to me and have provided me with parts that I needed for free, and there have been other people who have sold me parts for reasonable prices. And then you have those who seem to think everything they have is gold, and they seem to have this attitude: if you need it and I've got it, you're going to pay for it, you're going to pay dearly for it, or you're not going to get it. Now, if I run into the latter, as far as a flyback for this GE, then they're just going to have to hang on to it, because I'm not going to pay an obscene price just to get this TV going. You know, this is nothing really that valuable anyway. Now, if somebody offers me one for a reasonable price, then we'll go for it, but otherwise, no. Alright, that's enough rambling on. Let's get the back on this and move it aside, and we'll move on to other things a little bit later. And as far as that Syncor equipment, a friend who had a TV shop bought that stuff in the early to mid 90s, paid about 10 grand for it, and then when he closed his shop in 2000, he tried to give it all to me, and I didn't feel right about that, knowing how much he had paid for all that just a few years earlier, and I wasn't in a position to make him a fair offer on it, so I turned it down. Well, he ended up just letting it sit at another TV shop where it sat for years and they never used it, and then he went and picked up most of it. I think the TV shop wanted the capacitor analyzer, so he let him keep that, and then by this time he just brought it to me and said, "Here, take it." And I've used some of it, some over the years, but obviously now some of it needs some service. I'm going to have to open that piece up and try to free those switches up, or replace them with better quality switches. You would think as much as that equipment costs, they would have used better quality switches, but we all know how that goes. Alright, all back together and no screws left over. That's a good thing. Now all we got to do is just find a part for it. But anyway, as far as GE chassis progression, like I said, they introduced the AA chassis in the 10-inch sets to replace the Portacolor in '77, and then that evolved into the AB chassis. Then I think there might have even been an AC chassis. I know there was an AC chassis that was used in the 13 and 17-inch sets, but sometime around '83 or so, GE discontinued the 13 and 17-inch sets using the AC chassis and came out with the BC chassis, which was kind of an odd duck because the actual chassis was made by Matsushita, and then it was simply stuck in a GE cabinet with a GE tuner package, whether you had the electronic tuner version or the version with a mechanical tuner. And then those came in 13 and 17-inch varieties, and those like to eat flyback transformers as well. But for whatever reason, they continued to make these little 10-inch sets with the old A series chassis up through, I know at least through '85, and possibly as late as '86 when they got out of the TV business. As far as older GE color sets, most technicians don't think very highly of them, me included, but if one came my way for a reasonable price or better, even free, I would take it and play around with it. Probably the best GE chassis was the PC chassis, and then the PM chassis that was used in upper scale models that had the AV input jacks on them, and those were used in 19 and 25-inch sets. Unfortunately, they waited until the end almost to unveil their best, but the ones prior to the PC and the PM weren't really all that great. I remember the EC for the 19-inch sets and the EM for the consoles, 25-inch. Those had a decent picture, but they had the griplet problem, and they tended to lose flyback transformers from time to time. The 25-inch YM that preceded that chassis really loved to eat flyback transformers. And then you had the YA and the YC series chassis in the 13, 17, and 19-inch sets. Those like to eat yokes and focus dividers and flyback transformers. And then before that, you had the MA, the MB, and the MH chassis that was used in the solid-state 25-inch sets. That was probably their best solid-state chassis from the 70s. It used a Delta Gun CRT and a separate flyback and tripler. And then you had the QA and JA chassis. I think the JA was their first solid state. It was used in everything from 10-inch up through 19-inch sets with various modifications depending on what screen size television it was to be used in. The same for the QA chassis, and those didn't really have all that great of a picture from what I remember, what few of them that I've seen. But anyway, just a brief little GE chassis history to add on to all of the other ramblings. So I guess I've gone on enough, and hopefully you'll see a part 2, and you will if I find a part to fix this. Oh, and one final thought, it would have been nice had the flyback chose to release the magic smoke earlier in the game. It would have saved a little time here, but I think we've more than proven that the flyback is bad. Now, whatever else is bad, if anything else is bad, we won't know that until we get a flyback. But as of now, we know the flyback is history. It's done.